Welcome to Cadence Pointwise Tutorial Tuesday, where we'll show you how to use a feature or demonstrate a technique in just a couple of minutes. In this video, we're going to talk about the automatic volume mesh functionality. More specifically, we're going to continue our description of the global tab. So to illustrate this feature, I have in front of you the geometry of have a quadcopter with the surface grid ready to go. In order to access the functionality, I'm going to select all my domains and go to the Create menu option, and the second option right there is the automatic volume mesh. Once in there, I'm going to select the first option to let the software create that amazing far field for me. So we have another video where I actually described in detail all the options in the far field mesh frame. In this video, I would like to discuss the options that you have in the boundary mesh frame. As you can see, there is only one option at the moment, which is called boundary layer, and that is turned to off. So that actually indicates that you do not want boundary layers on your volume grid. If you were to want some boundary layers, so anisotropic cells on your volume grid, you would choose that option, the geometric growth option. And as you can see, all these additional fields are going to be presented to you. Now, these fields are the ones that will allow you to decide what kind of boundary layer you want to create. The first option that you have in there is the wall normal spacing, which is basically the height of the first anisotropic volume cell that grows off of your surface grid. The second option right here is the growth rate with a default value of 1.2, and basically this option indicates how fast your anisotropic volume cells are going to grow. A value of 1.2 for this parameter indicates that a certain anisotropic volume cell is going to have a height that is 20% larger than the previous anisotropic volume cell in the same stack. So after these two options, you have a subframe right here that is labeled the extrusion stop conditions frame. And you have four options in there. These options are the ones that will allow you to control when the local growth of the anisotropic volume cells should actually stop. The first option right here is the collision buffer, which is going to basically indicate how much distance you have between two anisotropic fronts that are in a collision course. The second option right here is the final cell aspect ratio. It has a default value of 1.0, which would actually be the aspect ratio of a perfectly isotropic cell. So when cells, anisotropic cells that is, are actually growing, if any of the cells reaches that aspect ratio that you have indicated there, they will locally stop. The next option in line is the maximum included angle. As anisotropic volume cells keep on growing, one of the things that is controlled before a cell is formally accepted is the maximum included angle of that cell. If that number reaches the number that is specified in there, a default value of 170 degrees, then the cell or the growth will locally stop. And last but not least, we have the centroid skewness that is set to a default value of 0.8. Basically, this parameter is a measure of the skewness of a cell with a number or a value of 0 being a perfect cell with no skewness and a value of 1 being a cell that is flat. So I'm going to go ahead and create my volume mesh, and very quickly Pointwise is going to assemble my block and create all the far field domains as expected. And we have one checkbox right here that will allow you to decide whether you want to initialize this block when you hit or click the OK button or not. In my case, I'm going to leave this unchecked, and my block is now created. If you like this video, be sure to click the thumbs up button and subscribe to our channel for more videos like this. If you have any questions or suggestions for future videos, drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a pleasant Tuesday.